Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 112 path sum. We're given the root of a binary tree and an integer target sum, and we need to return true if the tree has a root to leaf path such that adding up all the values along the path equals target sum. And we're told that a leaf is a node with no children. So in this example, 7, 2, and 1 are all leaves. So we need to return true if all the values that up to and including our leaf equal to our target sum. So in this example, our target sum is 22, and we can see this path over here, 5 plus 4 plus 11 plus 2 equals 22. So the root to leaf path with the target sum is shown, and we can return true because we know it exists. In this example, our target sum is 5, but there is no path from the root to any of the leaves, which gives us a target sum of 5. And in this example, the tree is empty, so there are no root to leaf paths, so we return false again. So, okay, let's have a look at how we can solve this problem. So we can use a depth first search solution for this. And what we can do is, for each level, for each reversal that we do of our binary tree, we can accumulate the total. So we'll increment the total in each level until we get to a root node, and then a leaf node. And once we get to a leaf node, we're going to check, is our accumulated total equal to our target sum? And if it is, return true. Otherwise, if it's not, return false. So let's start coding stuff up. Let's say our root and our total are going to be the two parameters for our depth first search function. And we're going to say our base case is going to be, if not root, return false. Fantastic. Now let's increment our total by root.value. Okay. And now we can say, if we are at a root node, so if not root.left and not root.right, and what this means is our node does not have a right or left node, which means we're basically at a leaf node. So we can say we're just going to return, does our total equal to our target sum? And this will be true if it does. So now we want to make sure we do this recursively. So we're going to say depth first search of root.left total, or depth first search of root.right, and also pass in our total accumulation so far. And then we can return depth first search of root and pass 0 as our starting total. So let's run the code, see what we get. And that's accepted. Let's submit and make sure we are fully accepted. And we are. We get an optimal solution and we pass all 118 test cases. So in terms of time complexity, well, we're going to be looking at an O of n time complexity. In terms of space complexity, well, because of the call stack and because of the nature of all DFS problems, as with any other DFS problem, the size is going to be O of h, where h is the size of the tree. So also the height of the tree. So I hope you guys found this video helpful, and I'll catch you in the next one.